This is a flip video about Dalton's law of partial pressure. Dalton's law of partial pressure is probably the easiest gas law you'll have to deal with. And it's quite simple. The idea is that you can have a mixture of gases seen here. And if you notice, this might be something like oxygen gas. This might be something like argon. This might be something like nitrogen gas. Notice they're all different types of gases. Doesn't matter what the gases are. But the concept is that all of these gases exert a partial pressure. Partial meaning they each have a part that they make up of the total pressure. So this makes up some of the pressure, and this gas makes up a different part, and this one yet another part. If you notice, these are bigger, medium, and small, so obviously they're going to have different pressure, different force hitting the walls, right? Whereas the big one might hit the walls at a higher pressure, more force, and maybe the small ones with less pressure. What Dalton's law says is if you add up all the parts of the pressure, then you get a total pressure of this mixture. Quite an easy concept. He has a very, very easy law that goes along with it, and that is total pressure is taking the pressure of the first gas plus the second gas plus the third gas plus however many gases you have and just adding them up. You could have just 2 gases, or you can have 200 gases. You just have to add them up. Now, something to make sure that you keep in mind is all of these pressures, when you add them, they must have the same unit. Doesn't matter what the unit is, it must be the same. So you might have to use your pressure conversions. Okay, let's take a look at a sample problem. You have a mixture of oxygen, nitrogen, and argon, very similar to the picture we looked at. The total pressure exerted by this mixture is 2.0 atm. That's the total pressure. If oxygen exerts a partial pressure, so oxygen's partial pressure is 1 atm, and nitrogen exerts a partial pressure of 0.6 atm, what is the partial pressure of argon gas? Okay, this is a little different. If we take a look at this, we're given a total pressure. That's on this side of the equal sign. So let's go ahead and fill that in. Total pressure is right here, 2.0 atm. And then they tell us oxygen gas. Oxygen is my first gas mentioned. So it has a pressure of 1.0 atm. And then they talk about nitrogen. Nitrogen is my second gas, and it exerts a pressure of 0.6 atm. And then the last gas they talk about is argon. Again, we could have had just a mixture of 2, but this gas sample has a mixture of 3, plus argon gas. So I'm going to say pressure of argon. That's, in other words, an X. That's what I'm solving for, is my X. If you'd like to set that to X, you can. Remember, the thing you want to make sure is that the units are all the same. If not, you should convert them. ATM, ATM, ATM. Great. So this is actually very easy. All I have to do is figure out what's X. So all I need to do then is move everything over to the other side. Okay? So this added up together, don't forget correct sig figs. One place after the decimal, one place after the decimal. I've got 1.6 atm on this side, plus that pressure of argon. Again, you could set that as X. And if I want to get this all by itself, I just now subtract. Be careful. Opposite of adding is subtracting. Whereas we were multiplying and dividing in the other laws, Dalton is adding, and then now we're going to be putting these on the other side, so we're going to have to subtract them. So when I'm done subtracting, my final pressure of argon, let's move this up a little bit, ends up being 0.4 atm. Let me rewrite that down here, 0.4 atm. So 1.6 plus 0.4 atm gives me the 2 total pressure of this gas sample. That's it. It's as simple as that. So the total pressure of a mixture of gases is equal to the sum of all the gases in the mixture.